Today we are going to discuss about Selenium Grid 4 and how we can use Docker to implement it. Let us start with the basics of Grid 4 first. So for this I have opened this particular link. It has explained the components and the architecture diagram and how these components are interacting with each other. Let us go through this. So the very first one is client, where our Selenium scripts are there. From here the requests are being sent to the router. Okay, now this request can be of two type. First, it is asking for a new node. That means a new driver initialization is required. The second is we are in between a test case where driver initialization has already taken place. We say we want to log in, where the Chrome or whatever the browser is that we have requested for has been initialized. So that means that particular request needs to go to that same node only where the earlier step of that particular test case were executed, right? So this happen with the help of this session map. This is a map which contains the node ID and the session ID. The request which is coming in, it also has a session ID involved with it. So in case router is able to find that session ID is already in the session map, that means new connection is not required, new driver initialization is not required. So request will directly go to the node. From router it will straight away go to that particular node, okay, on which the previous steps were executed. Now comes the case where a new driver initialization is required. For that, the request will go to the session queue. As now the session queue, as it is a queue, there can be multiple requests for new driver initialization. That means multiple nodes might be required. So these requests are served on basis of first come first serve. Okay. So from here, session queue, the request will go to the distributor, and distributor, as the name is suggesting, it will distribute these requests to the various nodes on basis of the requirement, whether it is needs to be executed on Chrome, Firefox, or other kind of configuration, maybe OS level configuration, right? So on basis of that, this distribution will take place. Now distributor, it is also responsible for, once the connection is established between the nodes, it will have the node ID, session ID. So it is also responsible for updating that particular thing in the session map, so that whenever the new step related to that test case come into the picture, session ID is already there, router will straight away send the request to that particular node. Now the last component is event bus. So event bus, you can consider it as a component which is enabling the communication between session map, distributor and nodes. So you see these dotted lines, that means these particular distributor, session map and nodes used to like need to use this event bus. As the name is suggesting, like whenever the communication is happening between these components, this communication is happening on basis of events mechanism. That means these component needs to publish to a specific location, and these uh, also needs to subscribe to a specific location, so that whatever the events are being happening, these components are aware about what other components are doing, right? So when we will be setting up the Selenium grid, we will be seeing that how we can enable these thing on these component. There are specific commands, specific arguments to achieve this thing, and we'll be seeing this in detail like when we will be implementing that. Okay, now let us go to the next section, which is talking about roles. Like there are, in this new Selenium grid 4, we have three, or I'll say four roles. Like you can also have Docker as a fourth role as well, but mainly there are three roles. One is standalone, the second one is hub and node, and the third one is distributed. Okay, so standalone means all of these components which we have discussed here, these are all residing on a same machine, single machine. Okay, and hub node means the legacy. If you know that in Selenium 3 we used to have hub and node system only, so this is also there, but internal mechanism is still based upon this, like these components. So in our legacy Selenium 3 grid, these components were not there. We just used to have hub and node. Okay, now whenever we are talking about hub node on basis of Selenium grid 4, that means the hub, it will have all of these components residing on the same machine. Distributor, event bus, session map, session queue, router, These all will be part of hub, and then nodes, as we know, like these will be different machines. The last one is distributed. Distributed is the one where all of these components are residing on the different machine. Okay, that means router is on separate machine, session queue is on separate machine, distributor is on separate machine. So this is required where like a lot of nodes needs to be configured, and one machine is not able to handle that kind of processing required. Now let us go through the Selenium Grid 4 related documentation, and we'll just see on high level that how we can establish these roles one by one. So for that, this is the link, and here if you see we have first role as standalone. For establishing the standalone, you just need to execute this command. You need a jar, which is their Selenium server jar, and it will be having a version as well. For Selenium Grid 4, you need to use the Selenium 4 related version. You can just check it on the Selenium website, and once you have the version, you can mention the role here standalone. So that means all of your components which are part of Selenium Grid 4 are on the same machine. You will get the IP address of your machine. The default port is 4444, and then you can point your remote WebDriver to that particular IP and port, and you will be able to execute your test cases. Hub and node, it can have two kind of scenarios. One is your hub and node is on same machine just like standalone, and the second case is like where hub is on single machine and then there are different nodes connected to it. It is just like Selenium 3, but internal architecture is completely different. In Selenium 3 we didn't have these components which we just discussed, but in here these components will be there. Now how we can see that like event bus and these components are there. So in case you are working with default port, uh, first of all, if you are on the same machine, of course you do not need to explicitly mention your event bus like publisher and subscriber. Those are not required. If you see here, your hub is this is the example where your hub and node is on same machine. You are not specifying anything, just the roles. That means you are able to execute, like establish, register your hub and node here. But in case you are requiring the multiple node there as well, because you are on the same machine, you are just giving the port and you are not mentioning anything else in regard of event bus. With now talking about different machines here as well, when you are using the default port 4444, like you will just need to trigger this command on your hub machine. Okay, now on your hub machine, like you haven't specified any different port, so on your node machine you just need to execute this command and pass your hub IP here, and default port is 4444. But in case you are not like this 4444 is being used by some other service and you want to use some other port, then that event bus that we discussed will come into the picture. So it will require publish event and subscribe event. See, you are mentioning the hub IP with publish event and hub IP to subscribe event as well. And as we discussed in this hub node, in at hub level, all the components, all of these five components are residing, right? So that's why node will be registering to this subscriber and publisher, basically the event bus. Distributed, as we have discussed, like all of these components will be on different machines. So first you need to establish the event bus. Again, the role will come after your jar, and you can specify publish event, subscribe event, and the port number. Then the session queue, this is the simple session queue role and the port on which you want to execute it. Session map, session map is linked with the event bus as we saw in the diagram, so it will need to register with our event bus. Distributor, distributor is connected with I think all of them, like distributor is connected with event bus, it is connected with if you see, this is session map, hyphen hyphen sessions mean, so it needs to send the event to session map as well. And then session queue, it is connected with session queue as well, it has its own port. Okay, and this is something which we can ignore for now. Then router, router has the session queue, event bus, and distributor as well, and it will have session map as well. So router is connected with all of them. The node, for node you just need event bus and nothing else, I guess. Yeah. So these are some basic commands because we have discussed about the architecture diagram. So these commands will look pretty easy now because whenever you see this publish event, subscribe event, you know we are talking about event bus, and similarly the other components, right? So let us go to the next part now. Now let us see that how we can decide which role we need to take in what condition. So it depends upon two things. One is the requirement that we have. The second is infrastructure support that we have. So in context of requirement, it depends upon how many test cases are there, how much time is currently test case execution taking, and what is our target time that we want to achieve. But the main thing is like what kind of infrastructure support that we have. So for deciding it, like these are some of the recommendation which are there on the like Selenium website. These are just the recommendation, and there can be exceptional cases as well. So we need to consider that in mind. And what is the recommendation? The first one is like if there are like distributor which are distributing the sessions, it is considered that if a distributor has 4 CPUs, it can distribute up to 4 sessions concurrently. So one CPU equivalent to one session in context of distributor. Similarly, for node, it is considered that one CPU and 1 GB of RAM means one browser session can carry on. Similarly, if there are 8 CPU and 8 GB of RAM, that means that particular node can have 8 concurrent browser sessions. The next one is that in case you have a machine where we have 32 GB of RAM and 32 CPU, so that doesn't mean that you can you should consider that as a single node and execute 32 concurrent sessions on that. No, ideally you should try to isolate your nodes. So in case you have such machine where you have this kind of processing power available, create multiple nodes with the help of Docker and on that particular machine, and then use that particular node for your test execution, right? And also these are some of the recommendation like which role means which kind of like it depends on the number of nodes, like which role you are using. If you have 5 or less node, then you can use standalone, you can use hub node as well. But in case you have 6 to 100 nodes, you shall not use standalone, you shall use hub and node. But again, this will again can vary. In case your hub is not that powerful, it doesn't have that kind of processing power, it might not be able to handle the processing of 100 nodes. Similarly, if you have more than 100 nodes, you need to have distributed role model, right? Now let us come to the demo part. So what we'll do, we'll start a Docker container with Firefox and in a standalone mode. Okay, and then so what we will be using in Selenium Grid for our demo purpose, this standalone for now. And then in future we'll go into the more details and see how we can achieve other things in Selenium Grid 4. The second is like we'll point our website WebDriver test to this particular our local host and the default port. And to see what is happening inside our Selenium Grid, we can then use this particular URL, and we can see how our test cases are executing. And if you see our Docker command, it will look something like docker run -d, it is for detached mode, -p, you are specifying the port on which this is your Selenium Grid, and this is the port where you will be seeing your test execution happening. And this is used to use shared host memory, like wherever your Docker is running, you are saying that allocate at least 2 GB of RAM for this particular container when it is running. And then this is your image name, version, and that's it, right? So for this, let us start with the demo. I'll open the command prompt. I'll copy this command. Docker ps. We don't have any container as of now. I've run it in detached mode, so I shall be able to come out of it. And now if I do a docker ps, we have a container running. We can just open these two ports here. Let me use edge only for that as well. So what I'll do, I'll go to localhost and 4444. So this is our Selenium grid, right? This is a standalone, and if we see what we have a Firefox, because we have used the image of Firefox here, right? And here you will find the details. It is saying that it is a Linux OS machine, and here you can see other details as well. So currently we do not have any session open. You can see the detail here. This is for overview. This is for help. It will take you to the Selenium Grid documentation. Now the next thing is we can check the other URL as well. So this will show us what is happening inside the container. As of now, no test case is running. So I have already created a demo project for us, and we can just go through this project. So this is a Gradle based project, and this is a basic build.gradle file where we have taken the dependencies in form of Selenium, WebDriver Manager, and TestNG. You can use the Maven project as well, but the basic remains the same. Here we have our test task where we are using the TestNG. uh, Before this task is executed, clean test will be executed, and this is the options for taking the command line argument. And then we are specifying the testng.xml file here, and this option is there for generating the testng reports, and this is for Gradle reports. Okay, now within our testng.xml we have used this login test. In this login test, what we are doing, we are taking a command line argument in form of exgc, sorry, and then we are initializing our driver. Once the driver is initialized on basis of whether it is remote or local, we are opening the URL and doing a basic login test with invalid credentials. Okay, and on basis whether it is a local or remote execution, this driver manager class is coming into the picture. We are calling this get driver method. If our command line argument is local, then local driver will be initialized with the help of WebDriver Manager and Chrome, and if it is a remote, then remote WebDriver will be executed. And here we are passing the remote WebDriver URL, like the one which we have initialized with the help of Docker image. And here we have basic Firefox option. So this is because the image is for Firefox, we have used Firefox option here, and we are maximizing and taking a implicit time and then returning the driver, right? So this is where our remote WebDriver is coming into the picture. And now what I'll do, I'll just quickly run a basic Gradle command first with local. We need Gradle EW and test, and here we can say -d exec equal to local. So this time a local execution should happen. We should be able to see the browser in our local system. It shall be a Chrome. See, a Chrome driver has been initialized. The URL has opened. invalid credentials are entered and our test case is passed, right? And we can see test ng report here and Gradle report will be here, though it is not required, but let us see. And after this we will also see the same thing for our uh, main our remote run as well. So this is index.html. Let me open it with Chrome. So it is saying there is one test and that has passed, right? This is our emailable report as well. You can check it as well here. Okay, so one test was there and it has passed, right? And you can see this was our test, right? Okay, let me close it, and now we'll do the same thing with the help of remote execution. This time as well our test case would pass, but we shall not be able to see any browser initialized here, but the browser will be initialized on this machine. This is our Selenium Grid, which we have executed using Docker. And here you can see the session. Active session is one here, and if you go here, just do a refresh. See, uh, now the browser is used Firefox, and we can see that no local not in local browser execution is not happening within our local browser, but it is happening within a Docker container. And we can see the site has opened, invalid credentials are entered. We see invalid credentials here, and now this will be closed, right? And if you see here, this is also minimized. Once the session is open, you can see the session information here as well. Let me quickly run it again. So this is our grid, and here we shall be able to see the session information. As of now, you can see session 0 sessions are there. Maximum concurrency at one time only one can be executed. Here we have session h1, and let me refresh it. It will take some time. So session has started. Yeah, now you can see once the window is opened here, only then you can see the sessions here. So it is saying that a session has started here. This is the session ID, and you are using Firefox with this version. This was the start date, and this is the duration. This is the node URI, and this is your test case has triggered. And if you see here, it was successful. Your report will be there, right? This time we can check build our Gradle report here. Let me open it in Chrome. Okay, Firefox has opened, and in the meantime we can also check the time of creation. So it should be near to this time. So this is your report, and if you come here, you can see the report was generated just now. So that means our test cases were executed within our Docker container using Selenium Grid. So this is it for this particular demo, guys, and I'll share the source code in my Git repo, and we'll share the same in the comment section of the video. In case you are liking the content that I'm making, please do like and share it with your QA friends, and do subscribe. Thank you, guys. See you in the next video.